Today we are going to deal with mechanism of enzyme catalysis. These enzymes are having many cavities on their surfaces. For example, let us take one model. Here I have something. These, let us assume as an enzyme. These are having many cavities. These cavities are of different shapes. When a reactant called as substrate comes, it is having a peculiar shape. It comes and settles in the cavity which is having the similar shape of this substrate. These cavities are called as active centers. These active centers are having some active groups such as amino group, sulfhydryl group, also called as thio, then hydroxyl group, carboxylic group. These active groups help this substrate to form a complex. That complex is nothing but activated complex. This activated complex later decomposes into product. Let us take down. Mechanism of enzyme catalysis. Enzymes are having many cavities called as active centers. Of different shape. These cavities consist of active groups such as amino group, then carboxylic group, then sulfhydryl group, then hydroxyl group, these groups help the reactant to come and form a complex. These active groups form a complex with the enzyme called as activated complex. Let us see how it works. It carries on in two steps. Enzyme combines with the substrate. This substrate is nothing but the reactant here to form a complex. This complex is called as activated complex. So what happens here? Binding of the enzyme occur. Binding of the enzyme occur. Later, this activated complex decomposes to form the product. Activated complex decomposes to form product. After this, we are going to enter into the new topic of this chapter. It is called as colloids. So next topic is colloids. So what is this colloids? Colloids are nothing but these are the particles having the size from 1 nanometer to 1000 nanometer. So the particles having size about 1 nanometer to 1000 nanometer. Also you can write it as 10 power of minus 9 to 10 power of minus 6 meter. Let us see actually how small this is. I am having a cube of 1 centimeter. At the side, the square surface area will be about 6 centimeters square. If I divide this cube into 10 power of 12 parts, then those cubes are equal to the larger colloidal size particle. If the cube is divided 1 centimeter side is divided into 10 power of 12 equal parts, then those cubes are the size of large colloidal particle. Let us see actually how these colloidal particles form a soul. For this, we are going to illustrate with a few of the solutions. So, we are going to arrange. I have arranged few things for you to tell you about some kind of solutions. Now, I have kept 4 beakers. Here, I have first beaker where solvent is kept, the water. In this, I am going to add salt. As already you know what is a solution. Solution is nothing but made up of solute and solvent. When this salt is added to this solvent, it completely dissolves. Why it is called as solute? It is a lesser part. Lesser part is called as solute and larger part is called as solvent. When these two combine, it is called as solution. Okay. Similarly, I am going to take this ink. Ink is a colloidal particle. This colloidal particle, when added to the solvent, it becomes sol. Okay, this solution is called as sol. So, ink as salt we called as solute. This ink is called as dispersed phase. This ink is called as dispersed phase and the solvent is called as dispersion medium. I am adding dispersed phase to the dispersion medium. Together it has become a sol. One more example we shall take about the sol. Solvent water is there. This is called as dispersion medium. To this dispersion medium, I am going to add dispersed phase as a gum. This gum, when added to the water, it becomes sol. So your gum is an dispersed phase and water is an dispersion medium. Okay. Now one more example we shall take. I have kept water as a solvent here. In this, I am going to add some chalk powder. This chalk powder do not dissolve in this. The particles you can see, they are scattering. Same thing is happening with the gum and water also. Same thing is happening with the ink and water also. But if you observe this salt and water, you cannot see any particles scattering in it. So what is happening here? The salt is completely dissolved in it. After after some times when you observe, the particles from this chalk powder are settled down, whereas the particles from this ink and this gum is added. Color is not changed, particle do not settle. Whereas if I take a filtrate and filter this, I will not get any sodium ion from this. Such kind of solutions are called as true solutions. If I take a parchment paper, not the normal filter paper, if I take a parchment paper, this parchment paper will filter the ink molecules. So all the dye molecules are remained on the parchment paper. Similarly, if I take the parchment paper and dissolve this gum and filter this gum, the gum will settle in that parchment paper. Same thing will happen with chalk powder and water also. The chalk is nothing but dispersed phase here. The chalk powder and water, if I filter, it will remain on the filtrate. But the difference here is after some time these particles are settled down, whereas these particles do not settle down. So the particles which are settled down in the solution is called as suspension, whereas these two are called as colloidal sole. After this, we are going to study about the characteristics. Okay. Now we are going to study classification of colloidal particles. Classification of colloidal particles. It is been classified into three types. One is depending upon physical state of dispersion medium and dispersion phase. One more classification is based on interaction. Interaction between dispersed phase and dispersion medium. One more is based upon size of dispersed phase. Let us study the first one. Okay, let us study now first classification based on physical state. Physical state of dispersed phase and dispersion medium. Let us draw a table now. We have here dispersed phase, then dispersion medium, then types of colloids, then let us see few examples of it. Let us go with the first one. If dispersed phase is solid and dispersion medium is also solid, such kind of colloids are called as solid sole. You can take an example of gemstone. If dispersed phase is solid and dispersion medium is liquid, then it is called as sole. For example, you can take paint, ink, Next, if we take an example of dispersed phase as a solid and dispersion medium is a gas, then such type of colloid are called as aerosol. For example, smoke, dust. Larger part is here gas and smaller part is dust particles. Next, if we take dispersed phase as a liquid and dispersion medium as a solid, such kind of colloidal solutions are called as gel. For example, cheese, butter. If the dispersed phase is liquid and dispersion medium is also liquid, then it is called as emulsion. You can find this in hair cream. If the dispersed phase is liquid and the dispersion medium is a gas, then it is called as aerosol. You can find this in mist, fog. If dispersed phase is gas and dispersion medium is solid, it is called as solid sol. Type of colloid is solid sol. Example, you can take it as pumice stone. You might have seen this pumice stone in your daily life. It looks like this pumice stone. It is very soft and abrasive to use. Then we shall move to the next. If dispersed phase is gas and dispersion medium is liquid, then it is called as foam. Type of colloid is called as foam. Example is nothing but a lather of soap. Foam. We cannot take an example of dispersed phase in gas and dispersion medium as a gas because these are homogeneous. What examples we have taken, all these are heterogeneous. Later we shall move to the next classification. Classification based on interaction. Interaction between dispersed phase and dispersion medium. Depending upon this interaction, there are two types of colloidal zone. One is lyophilic sol and another one is lyophobic sol. Lyophilic is also called as solvent attractor, whereas lyophobic, phobic is nothing but fear here. So we can remember it as solvent repeller. So definition of this, what it happens? It is nothing but a sol in which dispersed phase has the attraction towards dispersion medium. Here we can take it as the dispersed phase and dispersion medium are not having attraction. These are also called as emulsions, emulsoids, and these are called as suspensoids. The meaning is same. Emulsoids are nothing but there is attraction between the dispersed phase and dispersion medium. Suspensoid is nothing but there is no attraction between the dispersed phase and the dispersion medium. There are a few more examples of it. Next is lyophilic is a reversible, and your lyophobic is irreversible. Why it is said so? We had taken an example of colloidal stool as a gum. If the solvent dries up, if the gum dries, what we do is we add a little water in it, and that is again ready to use. So it is reversible. If the solvent is dried up, then you can again transform it into the soul. Whereas it is irreversible. What happens here? Lyophobic, little amount of electrolyte when you add, it is converted into the soul. After forming this soul is converted into the precipitate. After forming of precipitation, again you cannot get the original substance. So it is called as irreversible. This is called as because of this irreversible, we can also call it as this in stable state. Whereas irreversible is unstable. The layer separates. We can give you example. Lyophilic example we can give it as gum, starch, cellulose, and your lyophobic example can be gold soap. There is one more type of classification, third type of classification based on the type of dispersed phase. These are classified into three again. One is multimolecular colloid. Another one is macromolecular colloids, and next is associated molecular colloids. What happens here in multimolecular? The small molecules aggregate to form a particle of colloidal size. For example, you can take a gold soul. In macromolecular, these are already the size of colloidal particles. Here, in macromolecular, these are of two types. These are of two types. One is natural and another one is artificial. In natural macromolecular, you can take an example of protein, cellulose, whereas in artificial, the examples are polythene, plastic, nylon. Next one is associated associated molecules. Later we are going to study in detail about this associated molecules. Colloid. What happens here is there are many small molecules which spontaneously aggregate to form a colloidal size particle. Here, during this formation, there is called as micelle formation. Example is nothing but solution. In next class, we are going to study detail about micelle formation mechanism.